Hi, and welcome back to Wrench Wench Works. Thanks for joining us. Today we're going to cover machine tool startup. Now, just so you know, all my machines kind of have the same basic components. They start up about the same way, and the process is about the same. We're not going to just cover startup, though. I want to also cover what is going on in the process as we're starting up the machine. The reason being, a lot of the times people who are brand new to CNC might be turning on the machine saying, oh my gosh, it made a clunk, or it made a click, or a whiz, or a bang. There's 9 times out of 10 a logical reason for why it's making all that noise. And so I kind of want to just bring you through the workflow of what's going on with the machine, what is going on in the process of starting it up, so that if all of a sudden further down the road it doesn't make those noises, you can kind of go, okay, what am I missing here? It's going to help you later down the road become a better troubleshooter. Now today I'm going to use Lena. Lena is my largest machine tool. All my other machine tools do have the same components, and the startup procedure is going to be basically the same. The reason I'm using Lena is for multiple reasons. First of all, she's my biggest machine tool. I have the best access to her control cabinet so that I can do kind of a little bit of a breakdown of the different components that are at play during the startup. And also because she is so big, she makes my butt look smaller. Welcome to my shop floor. So I wanted to scooch down here real quick because before we do the power on procedure, I thought maybe we could just cover a couple of these components that are in Lena's control board here. So just so you know right off the bat, I am not a professional electrician, and this is just a very, very, very brief and basic overview. Please don't nail me on, hey, that's not exactly what that's for. This is just kind of a general, broad description of what's kind of going on underneath the hood here. So we have here it's the power transformer. It's that big brick. So that takes all that primary power that's coming from your wall into the machine and turning it into power that Lena here can use. Right next to the transformer, we have a DC bus board. You'll see the DC bus board has a whole bunch of little fuses and everything in there. So the DC bus board actually takes that power and kind of like a Greyhound, distributes that power to the different peripherals and the different components in the machine. Right next to the DC bus board here, I have a capacitor. The capacitor kind of works a little bit like a rechargeable battery in a sense. So when Lena needs a little extra oomph, it's probably coming from here. Let's scooch down below here to this little guy that looks like an ice cube. So that is a driver relay. And a driver relay kind of allows a little bit of current to control higher powered accessories like drivers and other components in the machine. Right next to the driver relay, we have here a contact block. So now when we're booting up the machine, that is actually going to be that click or that clunk that you hear. How a relay works is we have all these wires kind of coming in from the top and the bottom, and you'll see there's kind of a little pushy button here. Well, when you energize the contact block, so right now it's not energized, and so all those wires are kind of separated. But when you energize the contact block, what you hear is that clunk as it goes in, and now the wires are all touching and it closes that circuit. And this is primarily for the spindle drive, which you'll hear people call it a VFD, a variable frequency drive. Basically, this controls the spinny bits of Lena here. Right below here, we have a breaker box. Most people are familiar with breaker boxes. So if you run into a situation where you're overcurrent or it's not handling the load, one of these little switches will turn off, kind of like if you're trying to run your heater and your shop vac and your coffee maker all at the same time. Right next to here this is actually your power supply. So this power supply actually runs a lot of the peripherals. For example, the logic boards, the fans, and the control box. So this kind of is for all this peripheral, those little thingamabobbers that the machine uses to run. Right next to it is an EMI filter. this EMI filter is just to filter out all that electrical noise, especially with, machine tools like this. You don't want a lot of electrical noise. It can start doing like weird things where all of a sudden you start losing control of your mouse or your keyboard or your controller. It just kind of filters it out and gives you good clean power that you can use in the machine. Right next here, this big green guy, that is your main control board. So this is kind of where all the action's going on. So you'll see there's a whole bunch of different cables and stuff going in here. It controls the communication, the power. It's basically the brain of your machine. Right above it, you'll see these 4 little black boxes. These little black boxes are called drivers. Now, all my machines are stepper driver driven, and we'll be getting to that in another video. But just so you know, this is kind of the middle management for the motion control, the linear control of the machine. The stepper motors don't have a way to independently think on their own. And so these drivers are actually, when you send a motion command through the controller telling it, hey, I need you to move or scooch over 3 inches in X, the X driver will actually convey that information to the X motor, and then it'll execute the motion. There's 4 drivers in mine because we have the X axis, the Y axis, the Z or the Z axis, and then here I actually have my A axis, which I do have a 4th axis. I don't have her on the table right now, but we'll be covering 4th axes again in another video as well. So without further ado, let's kick her on and let's show you how she powers up. All right, I hope you pardon my dust bunnies. I just scooted underneath my polishing bench here so I could show you this real quick once. So here's the main control or main power switch. And right next to her is actually an industrial chiller. That is for Lena's spindle. Lena, because she runs at high RPMs, needs a way to keep her cool so she can continue to do that without overheating. And so this actually pumps water through the system as she's running so she doesn't overheat and hurt herself. So that's what's going on back here. Okay, we're going to boot up old Lena here. So the first thing we're going to do is turn on the main power switch. And the first thing you're probably going to notice is you're going to hear a fan kick on, or you should hear a fan kick on. And you're probably going to see some blinky lights here on the main control board, and that's normal. That means that the machine is getting power, but at this juncture, it doesn't quite know what to do with it. And also, while we're down here, I'm also going to throw on the chiller for the spindle unit. And the chiller does go beep, 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 beep to let me know that I just turned the chiller on. And you'll probably notice we have a green light down here and also a yellow light. And that means we're ready to start booting the rest of her up. So now that we've thrown on the main power switch, we need a way to control Lena. So Lena's controlled with a controller, which is basically just a little computer for your CNC machine. You'll see mine's just in a little itty bitty box here. This is a Linux box. I use PathPilot right now for my interface, built off of Linux CNC scaffolding. So this little tiny guy actually controls all of Lena's programs in motion and errors and feedback and everything else. So this is essentially her big brain and a way for me to control her and convey to her what I want her to do. So as she's turning on, you'll notice there's kind of a splash screen. It's going through a bunch of stuff. Once she boots up, what we're going to want to do is enable it so she can get power to all her other bits. In order to do that, we're going to have to kind of remove the parking brake, as I like to say, which is this big red button here. This is your emergency stop button. I generally use it when I park the machine or when I have big moments where I'm like, yikes, that's bad. Let's hit the e-stop button, because that's going to disconnect pretty much all the motion control and everything from the machine. So hope you never have to deal with this, but the e-stop button is generally, you want to be within reach of it just in case you get stuck in the machine or something occurs where you need to power down real quickly. That's why it's big and red. So you'll notice she has her interface up and rearing to go. You'll probably also notice, and I don't know how hard it is to see there, but you'll probably see there's a flashing reset button. So she's telling me that she needs to reset. However, from this standpoint, I can sit here and hit the reset button until the cows come home, and she isn't going to do anything because we still have the e-stop button on. So what I'm going to do is just turn this button clockwise, and you'll hear it pop. So that means I've released the e-stop, and that means I am ready to start energizing the rest of Lena. So one thing I want you to notice is I'm going to be hitting this blue button, but I'm probably going to give you another angle here, because as I hit this cycle start button or this reset button, you're going to notice a whole lot of other stuff going on down here. It's a lot more exciting to be looking down here as I hit the reset button than to be looking at little old me. All right, taking a peek in Lena's main control cabinet here. Once I hit that reset, there's going to be a lot going on here. You're going to see a little bit of a light show. So once I hit reset, she is going to ready the drivers. She's going to ready everything so that she's just about ready to get cooking. So we're going to hit this. Just so you know, my lights might flicker ever so slightly. It has more to do with me living in an old house, and I have still have to get my auxiliary panel hooked up here out in the shop. So, but you'll notice I'll hit this button, and you probably saw my lights flicker there, but you probably saw all those drivers power up, and you probably saw a bunch of other little green buttons going on, and that means that everything is working properly. Okay, so now that we hit the reset button down here and everything seems to be copacetic, we're going to go ahead and hit reset on the controller, and it should just stop blinking. If it doesn't stop blinking, chances are you're probably on a limit switch, which I'm really excited because we are getting to limit switches next. So, limit switches, referencing, and stepper motors. So as I mentioned previously in the video, all of my machines are driven by stepper motors, which for all intents and purposes, I like to call dumb motors. Now, it's not because I'm mean and I like to make fun of my little motors here. They actually do a pretty darn good job for what they are. But stepper motors do not have memory. They don't have a way to directly talk to the controller. Those little drivers, those 4 boxes down there, those are the middle managers. So when I tell the machine to move in one of the axes, the controller actually tells one of the little black boxes, or the driver, which then conveys the signal over to one of these workhorses, which is the stepper motor. So when a machine first turns on, because the motors can't talk to the controllers, they don't know where they are. They wake up and they're like, where are you? It has no idea where in space, where on this whole machine all the axes are. It's kind of like waking up on Saturday morning after a really good Friday night fish fry, where you maybe had 1 or 2 too many old fashions or shots of Januvka. It needs a way to kind of get its bearings. And so what a limit switch is, for example, on Lena here, hers are proximity switches. So you can see these little orange boxes. And what happens is you send the axes to move in a particular direction. So when I hit that reference button for each axis, it's going to move towards the switch. Once this prox switch actually senses where the axis is, it'll stop and it's going to register it in the control. Now, there are different flavors of limit switches. So hers, you can see here, it's more of a proximity switch. When we get to Oli's is more like a physical squishy little button. So his is a little bit more violent. He basically keeps running until he runs into the physical button, and then he backs off, and then it notes where it is in time and space. The reason this is really important to know is if you are in the middle of a program and you go ahead and smash that e-stop button, it's going to lose its memory. It's not going to know where it was. Every time you power on the machine, these stepper motors need to know where they are, or the control needs to know where the stepper motors are. So you're going to have to run it back to that reference switch location so it can record where it is again. This can really affect the accuracy of your part. So if you do hit the e-stop button and you have to re-reference, chances are when we get to this point, and I know if you've never run a CNC, this might seem a little up there, but I promise it's going to make sense later. When you do go back to run that program, you're going to want to go ahead and verify your part location in regards to the center of the spindle and the axis location. So let's go ahead and reference this girl. You know what? Before we go ahead and reference Lena over there, I do kind of want to scooch in here real quick and show you on Olaf this other style of limit switch. So you'll notice here we got this little squishy wheelie button thing. So that's the actual physical limit switch for Olaf here. And down below him, you're going to see a dog, which is nothing like diesel or clutch. It's actually just a surface for that limit switch to butt up against as we send it up to its reference position. So what I'm going to do is go ahead and I'm going to jump into the control here and just hit this REFZ or reference Z button. And you should see it scoot up. And what it's going to do is it's going to go ahead and hit that proximity switch, or not proc switch, it's going to hit this limit switch, and it's going to roll back down. Once it kind of finds its location, it kind of settles, and then it records that location into the control panel so it knows where it is. So Lena's ready to have me reference her limit switches. However, there's one little caveat with Lena. So her Y-axis proc switch is not functioning properly right now. So you're going to get some bonus material. You're going to learn how to do it the right way on a properly functioning machine. And I'm going to also show you how to kind of fudge it if you have a limit switch or a proc switch that isn't working correctly. One little note with this is if you're doing high tolerance stuff and it's really important that repeatability to a feature is, important, probably don't use this method, but for me, for what I do here, it's really not that big of a deal. So I really haven't been hot to trot to get her all fixed up, at least not on the reference switch, because it's workable for me. So first things first, we know that the X and the Z work. So we're going to go ahead and hit reference Z, and you'll see the heads going up. The proc switch in the Z is actually near the top on the right-hand side of the spindle when you're facing it. And then you'll see here, it's going to scooch all the way over here. And it goes kind of slowly, and that's because that way you don't get a lot of bounce back and stuff. It's not going to go whipping right towards the limit switch, but then once it senses the switch, there's a little flag back here. It should, stop and then kind of back off ever so slightly, and she did. So let me show you how I kind of cheat or fudge my Y-axis. Okay, so with Lena's Y-axis, because the reference switch is not working on her, what I like to do if I want to fudge it is I go into the settings screen, and depending on what controller you have, like on PathPilot, the settings screen is right under this tab. You should be able to turn off your limit switch. It's usually going to give you a bunch of jargon about, hey, just so you know, if you turn off a switch, things are going to be bizarre and might not function the way it should. I know that this method works because I've been using it for the last 6 months. So we're going to go ahead and hit OK. So we're aware the limit switch is off. And then what I'm going to do is I'm just going to jog her forward using, let me back up so you can see this a little bit. Using this jog pendant here, I'm just going to slowly creep forward with her. She's going to hit kind of a hard stop, and she's going to go da 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 da. I'm not going to go fast because I don't want to damage her. But once she kind of hits there and bottoms out, then I'm just going to go over here and call that my Y reference. And then I'm going to turn my limit switches right back on so I don't forget to turn them on the next time that I can turn the controller on. So basically, I'm kind of fudging it. I'm acting as the limit switch in this case. So I'm just telling it, hey, you're at the end of your axes. Go ahead and record that number right where you're at right now. So I'd like to apologize for the audio in this last segment. As it turns out, I am a bit of a brute, apparently, and I went to pull out my microphone dongle and managed to break it off into 3 pieces with just a wee little tug. So I'm kind of going sans microphone for this last part, but it is the final part, and it's kind of the fun part because you kind of get to see some of the electronics at work. So what we're going to do is kick on that spindle drive. Now, you do have to initiate the spindle to turn on for the VFD to turn on at least that first time. Once that contact lock opens up, that little piece at the beginning that I told you kind of goes clunk and everything contacts and it turns on the spindle drive, you're going to actually physically be able to see that. I just want to show you on this end what I do to make that happen. So all I'm going to do is, you see here we've got the spindle commands right here. We got stop and forward. This guy doesn't go in reverse, or Lena doesn't go in reverse, neither does Olaf. So what I'm going to do is hit spindle forward. It's going to go wind up to 10,000 RPMs, but in order for it to wind up, it actually needs to turn on the physical spindle drive. So as I hit this button, you're going to see that contact block pop out, and you're going to see that VFD turn on, and I just think it's kind of neat, so I wanted to show you guys quick. Okay, so what I want you to watch is, I want you to watch this little contact block right here, and also watch the VFD. So I'm going to pop up and go ahead and hit spindle start on there, and that should energize this and bring it in so that those wires are all contacting, and that will energize this spindle drive here. So give me one moment, I'm going to pop up and hit forward, and let's see what happens. And I can see from up here that my spindle is whipping around at 10,000 RPMs, and the VFD here is going to give you some output, just kind of giving you an idea of what's going on at the top there. And just so you can see what's happening top side, there's the spindle, and it is running at approximately 10,000 revolutions per minute. So now that we've covered most of the startup process of starting up the CNC machine, I'm going to go ahead and just real quick go through the power down procedure. One thing that I like to do, and it's a personal preference thing, but I always like to park my machine so that it's not super close to where the limit switches are. Reason being is, when you power up, one of the first things you always do is reference your machine. If it's too close to the proc switch or the limit switch, it will start booking towards that flag or that dog, and it'll almost kind of bounce off it. It just kind of, it does this herky-jerky thing, and I don't think it's great for the machine. So what I'm going to do is just kind of roll away from the limit switches, so the next time I power her up, she's just ready to hit ref X, ref Y, ref Z, and be ready to go, and I don't have to worry about over-traveling or having to disable my limit switches. And so I'm just going to go ahead and give her a little jog. So I'm just going to jog her back. I like to jog her towards the center of travel, just kind of a force of habit. With like CNC mills, I got into the habit because a lot of the times you'll have like a fourth axis or a vise on the end, and it's not great for the saddle when you park it way over on one side or the other. Through time, you can actually get a bow in the saddle. Something, again, we can cover in the future, but for me, I just personally like to move all the axes down so you can kind of see I'm somewhat in the center of the travel, and then I'm going to go ahead and scooch that head down a little bit. One other thing with Lena is one of the early prototype models, so her Z-axis brake doesn't always work. So sometimes when I hit that E-stop, sometimes the head just likes to drop down a little bit. And I don't worry so much about this tool. It's not going to hurt itself. It's just going to gently bump up against the MDF. But let's go through that shutdown process really quick once. So all I'm going to do is parking brake. I'm going to go ahead and hit the E-stop. When I hit the E-stop, it's going to tell me the machine's been E-stopped. And then I'm going to go ahead and I'm going to hit exit on the controller. And so it just told me that, hey, we'll let you know when it's okay to turn off the power. And then I'm just going to scooch back behind the machine, hit the main. Yep, so you can see it's now safe to turn off my controller. I'm going to scooch back there and just turn off the chiller and turn off the main power switch. Lena and I would like to thank you for joining us into our little foray into CNC machine startup. So if you have any questions, comments, or feedback, please feel free to drop it in the comment section. I am happy to address as much as I can. In fact, I live for it 9 times out of 10. I'm going to learn something new as well. It's really tricky with shooting a video as opposed to teaching a class because, like a stepper motor, I am not getting any feedback or any direct feedback on the other end of the camera. And so the only way I'm going to know what you guys want to learn or if I need to clarify something is if you just go ahead and tell me. So I hope you've enjoyed it. I hope you learned a little bit of something, and we will see you next time. Bye.